Hey guys, let's talk about a few problems in section 310. In this video, I'll be discussing 1, 4, and 9. There's several other videos where I do other problems in this section. The first problem here, it's one of those problems that it's so easy it can be thought of as complicated. And what I mean by that is typically when we have the volume of a rectangular solid, we say it's length times width times height. Well, in this problem, it's giving you, it says John's bathtub is rectangular and its base is 18 square feet. Well, that 18 square feet take the place of the length times the width in my volume formula. So my volume formula simply becomes, instead of length times width times height, just 18 times the height. Now, it's wondering how fast the water level is rising. So please keep in mind, it is asking you what the change in height with respect to time is. So we're asked for what dH dt is if John is filling the tub at 0.7 cubic feet per minute. Well, that's the change in the volume of the tub with respect to time. So you're given dV dt is 0.7, and now we need to find what dH dt is. So I can go into the problem and say, well, okay, we should be able to find every bit of that. You go back to your volume function, take the derivative with respect to time of both sides. On the left-hand side, you simply get dV dt. On the right-hand side, you'll get 18 times the derivative of height with respect to time. So now, once you start plugging things in, we know dV dt was given to be 0.7, so that allows us to solve for dH dt. We just say dH dt is going to be that 0.7 divided by 18. When I went to my calculator, I got 0.03. It was actually 88 repeating, but Achieve is wanting the answer to 3 decimal places, so I'll say that's just going to be 0.039, and I'll check that answer here. And you can see correct. Now, if we look at the next one, in the next one that was asked, number 4, here's where I worked it on the document camera here. So for this problem, it's telling you that the first thing here is that assume that the radius of a sphere is expanding at a rate of 90 centimeters per minute. So that very first sentence, I went right here. You're given dr dt, the change in the radius with respect to time, is 90. Now, you know at the point of interest, it says you're looking for the rate at which the surface area is changing when the radius is 40 centimeters. So the radius is changing at a rate of 90 centimeters per minute, but the instant we're interested in, the radius is 40. Now, what are we trying to find? You're trying to find the rate at which the surface area is changing. So you're given both a volume formula and a surface area formula. The only formula you need in the problem is the surface area, because you're trying to find the change in the area with respect to time if you know that the radius is increasing by 90 centimeters per minute when the radius is 40 centimeters. Okay, so I go to my area function. Derivative of the left-hand side with respect to t is just change in area with respect to time, dA dt. On the right-hand side, please remember that r can be thought of as your differentiable function over there. It's a group to the second power. You know the chain rule says bring the power down in front, multiply, I get my 8 pi r to the first, then times the derivative of what was in the inside. Well, what's in the inside is the radius r. Take the derivative of that with respect to time. That's where the dr dt comes from. So I get 8 pi r dr dt on the right-hand side. Now it's just a matter of solving for the change in area with respect to time. Everything else, we're told, r was given to be 40. Dr dt was given to be 90. So then I can take all this information. I just took 8 times 40 times 90 on the calculator, and I got my 28,800 right here. Left it in terms of pi. We know that that's in square centimeters per minute. That should be the answer here. So I go to Achieve and I say 28,800, and I think they always want the pi left in there, so it's a nice exact answer. I'll check that answer, and it says correct. Now, the next one in this section that someone was asking about was number 9. Number 9 is an interesting question. It can be challenging if you don't understand the concept of similar triangles. So let me talk about number 9 here with you. So in this problem, you have a street post that's 5 meters high. You've got a guy that's 1.9 meters high that's walking away from it. And it says that he's walking away from it at a rate of 1.4 meters per second. So you see that's why I labeled this the guy walking away at a rate of 1.4 meters per second. Now you're asked for how fast the shadow is moving away from him. So the goal of this problem is dy dt. At first, you don't think you're given enough information because you don't have a clue how far he is away from the street post. It doesn't give us any information to find that. Turns out it's not actually necessary. The way that we should solve this problem is the concept of similar triangles. Please notice the large triangle is going to be formed by the street post and the tip of his shadow, which I'm calling C. That's the large triangle. You have to assume that the street light is built at a 90-degree angle. Now you also have to assume he's walking away standing upright, so he's walking at a 90-degree angle. And then please notice the large triangle ABC would be similar to the small triangle DEC. A and D are both 90-degree angles. They both share the angle C, thus angle B must equal angle E, making these similar triangles. Now, anytime you have similar triangles, we have opposite sides are proportional. So what I mean by that is I could say, well, then the easy way to think about this, and I like to keep all the sides of the large triangle under the large triangle, I can say the height over the base of the large triangle, 5 over the base of the large triangle is x plus y, should equal the proportion of the height over the base of the small triangle. In other words, 1.9 over y. That proportion must be true since these are similar triangles. After that, all I did is I cross multiplied and said, well, 5 times y should equal 1.9 times x plus y. Clearly, I'd have 1.9y on the right-hand side. I subtracted that on the left to get the 3.1y is equal to 1.9x. And then I can say, well, if I solve for y now by dividing by 3.1 on each side, instead of saying 1.9 divided by 3.1, which you certainly could have, it's the same thing to say 19 over 31. Now I can say, well, all right, I have an expression, solve for y in terms of x. Why not go ahead and take the derivative? Easy to take the derivative now. Derivative of the left-hand side with respect to time is just dy dt. The derivative of the right-hand side with respect to time is just going to be 19 over 31 times dx dt. At that point in time, you already know what the change in x in this problem is. His distance from the street light is going to increase by how fast he's walking away. So the dx dt in the problem is 1.4. I took that 19 over 31 multiplied by 1.4, and I got my 0.858, and we know that that should be in meters per second. It did say round to 3 decimal places, so now this should be the answer that we plug in right here, 0.858, and check that answer, and we see that that answer is great. Hopefully this helped you out with these 3 problems in section 310. Let me know if you have any other questions.